Hello, we're looking at problem number 1 in your Geometry Part 2 textbook. This is found on page 578 in your textbook. This particular problem is trying to identify equal measures by doing different kinds of transformation. Now, it says the composition R of 90, P means that it is being rotated 90 degrees around point P, and this means right here that it is being reflected over the n-axis. That's what R sub n stands for. So if we took LMNO, which is apparently what the original one was, and we're going to rotate that around P 90 degrees. Okay. Now the reason that works is because that right there would be 90 degrees, or if I did that one to that one, it would be 90 degrees, and so on. Okay, so it's being rotated 90 degrees around point P, and then once you get to this point, which is trying to show you that what it would look like after rotating, then you're going to reflect it over the line here that they're calling line N, and if you were to reflect that over that, then it becomes this, which is G, H, J, and K. So if I were to rotate this, that means that, of course, O would be here, L would be there, M would be there, and N would be there. So what they're trying to show you is that once you reflect it, L and G are going to match up with each other, which is what they're trying to say here. That M and H would match up. That's those two right there, and so on and so forth. So that's what they're trying to say. Then it says which sides have equal lengths. Well, remember, by definition, isometries preserve distance. Now, isometries simply mean if you could move it, slide it, or reflect it, and you keep the same shape, that's what an isometry is. So corresponding sides are going to have that. So that means, again, that LM is going to match up with GH. And MN, which is over here, is going to match up with HJ when it's reflected. And line NO, which is the bottom, or the side one over here, is going to correspond with JK. And then LO is going to correspond with GK over here when you do that. Okay. Now, in the got it section, it says the composition is going to be, you're going to take a triangle which is called ABC. So I'm just going to take a simple triangle, sketch it here, and I'm going to call that ABC. Okay. It is going to be reflected over a line that we're going to call T, and then it's going to be translated or slid 2 to the right and 3 up. Okay, so I'm just going to draw a line right here, and I'm going to call that line T. It could have been any line. I just happened to draw it up and down. It could have been below it. It could have been catty-cornered or leaning. That part's fine as well. It's just easier to show this way by doing it straight up and down. So we're going to reflect that over that line that we call T. Now, these should be the same size. I'm just trying to do this quickly. So anyway, your B is actually right here. Your A gets, once it gets reflected, is here, and of course C stays the same as it was. Now, once we do that, if we now slide that up by going 2 places to the right and 3 places up, if I took each one of these and I went 2 places to the right and 3 up, then that would be there, A would be here, and C, go 2 places to the right and 3 up, it would end up being up here. Okay. Now, they're saying to call that, remember, A has to match up with X, so your X is going to go here, B is going to match up with Y, okay. So that means that your Y is going to be here, and that Z is going to match up with C. So we're going to call that Z right there. Okay. So notice that angle A is going to be congruent to angle X. Angle B is going to be congruent to angle Y. Angle C is going to be congruent to angle Z. And then if you're trying to do segments, AB is going to be congruent to XY, and AC is going to be congruent to XZ up here. I'm just comparing back and forth between these two. And then finally BC, which is that one right there, is going to correspond with YZ. So BC corresponds with YZ. Because remember again, isometries mean that they keep their same shape, their same size, and that the sides are all going to be equal to each other, as well as the corresponding angles are also going to be equal to each other. And that preserves what we call isometry. Okay, best of luck on this. Hope that made sense.